This is Dr. Sajja Suneel from Data Science Department. Today we are going to discuss about unipolar and bipolar stepper motor sensors and light sensors and temperature sensors with thermistors. These are the three concepts which I am going to discuss with you today. These are the concepts which are taken out from a third module in Principles of Internet of Things, that was controlling hardwares and sensors. Why controlling hardwares and sensors will play a major role in these Principles of Internet of Things. Without controlling Internet of Things, it is not possible. Without controlling hardwares and sensors which are there in a particular IoT system, is impossible to extract the data, to analyze the data, to take some decisions based on that particular data. So we need to take control on these particular hardware devices as well as some sensors which are used in any kind of IoT system. For that purpose only, we need to know what exactly these hardware components are and what exactly these sensors are. So in today's class, as I told you, today I am going to discuss with you about unipolar and bipolar stepper motor sensors. What unipolar and what bipolar stepper motors are, and how the sensors will play a major role in these stepper motors. Sensors and actuators will play a major role in any kind of IoT system. These two will play a major role. We are talking n number of times about these sensors actually. Why? Because sensors play an important role in Internet of Things in any kind of IoT system, because sensors are the one which are going to acquire the data from the things, from that particular object. So without sensors, it is not possible to extract the data, right? Sensors are the things which gives information, and along with that information the actuators are going to respond. Okay, fine, let me tell you what exactly we are aimed for and what exactly we are going to get after a successful completion of these three topic discussion. Let me enter into the concept first. As I told you, we are discussing these topics from module 3, which is controlling hardware and sensors. In this controlling hardware and sensors, have a look guys how the things are. In the previous sessions, I have narrated you about controlling hardware, connecting LED, buzzer, switch high power devices with transistors, controlling AC power devices with relays, and controlling stepper motors and speed controlling of DC motors. In today's class, as I going to discuss with you about unipolar and bipolar stepper motor sensors and light sensor and temperature sensor with thermistor. And these are the three topics which I am going to discuss with you today. And after successful completion of these topics in our future class, I am going to discuss about voltage sensor, ADC and DAC, and temperature and humidity sensor. And coming to the motion detective sensor and wireless Bluetooth sensors, level sensors, USB sensors, embedded sensors, distance measurement and ultrasound sensors. Like this, there are several sensors which are going to be used in our IoT systems. Right guys, have a look. Excuse me. What we are going to aim for learning about these stepper motors, right? The main objectives and outcomes for stepper motors. In these stepper motors, there are two different types of stepper motors, as I told you, unipolar and bipolar. These two are going to share a specific things. The main objective of these particular unipolar and bipolar sensors are you need to provide a precise and you need to control angular rotations which are going to be achieved by converting the digital electrical pulses into discrete step of rotation. This is what the main objective which is aimed for. From these two things, these are the things which are going to be provided, such as unipolar and bipolar stepper motors. What are the outcomes which we are going to be achieved in unipolar and bipolar? First we will see in unipolar. As I told you, by successful completion of this particular topic discussion, where these are the outcomes which are going to be achieved by unipolar stepper motor. Coming to the first one, here we are having simple control circuits. What we are having? Here we are having simple control circuits which are very easier to drive due to simpler windings, due to simpler winding configuration, and also here the cost is very low. Why? Because here we are not going for higher complexity designs, we are doing only less complex designs, so which leads to a low price point. For that purpose, I can confidently say that unipolar stepper motors are low cost. And why? Because we are choosing only less complex designs. For that purpose only, the things are going to be getted in a low cost. And the next one is low torque. Why low torque only? Now why we are not getting high torque, sir? Why? Because here whatever the coil winding, whichever been used by us, only we are doing half coil winding. For suppose, take an example, this was the coil. For this I am winding with a copper wire half only. So due to this I am only getting lower torque. I am not getting the high torque. I am getting only lower torque, which is resulting low torque outputs. And along with that, we are having lower efficiency. Why? Because here we are wasting energy by not fully utilizing the windings. Why? Because there are more chance for completely utilizing, but we are not utilizing. For that purpose only, we are getting low efficiency. And this is the last factor, which is lower speed. Why? Because torque is having some limitations which are going to be affected by the achievable speeds. This is how the outcomes for this particular unipolar was. And now we will see the bipolar outcomes, how the things are in bipolar stepper motor. Coming to the first outcome which we are going to be achieved in bipolar stepper motor was higher torque. As I told you, when you compared with unipolar, in bipolar we are getting a high torque, we are getting high efficiency, we are getting high speed, and we are using more complex designs, and the cost is also increasing. Why? Because we are using the max, we are using the highest things. So for that purpose only, everything is going to be in higher format. Coming to the first point which we are going to be achieved by using this bipolar stepper motor was the higher torque. Why? Because we are fully utilizing the windings, which leads high torque output. And also the second one, higher efficiency, more efficiency, the usage of the power for better performance compared to unipolar. And coming to high speed, great torque, which allows for achieving high speeds. And coming to the next one, which is more complex control circuits, which requires a H bridge or a similar circuitry to reverse the current. For this purpose, we are using more complex control circuits. And coming to the last factor, which is cost factor. Here the cost was high. Why? Because we are using more complex designs, which offer leads to highest price points. These are the outcomes for bipolar stepper motors. And have a look, what are the different kinds of sensors? As I told you, today I am going to discuss with you about unipolar and bipolar stepper motor sensors. And the next thing which we are going to discuss was light sensor. And before entering into that subject, I just clarifying you what we aimed for and what we are going to get at the end of course. As I told you, in principles of IoT, which is a physical IoT devices, where it refers the aspects of Internet of Things, the objects which are connected to Internet. The physical objects are integrated with the digital world. How the physical objects are integrated to digital world? For suppose, let us assume how many physical devices you guys are having. You are having a smart gadget, you are having a smart laptop, and you are having a smartwatch. With you only there are 3 to 4 devices which are connected to internet, and all these are integrated in a digital world, right? So sensors are playing a crucial role in this particular IoT system. Why? Because these are going to be used for collecting the data from the physical environment. I'll tell you some examples of these particular sensors where our principles of IoT applications along with that specific thing. The first one is light sensor. What was the main objective of light sensor was? The first one is light sensor. The objective of this light sensor was we need to measure the light intensity. What was our objective in light sensor? We need to measure the light intensity. Why the light intensity has to be measured? If for suppose, let us assume I am having a smart home and you came as a guest to my home. In that place, you notice that the smart light sensor, with the help of smart light sensor, whenever we are chilling out or we are watching a movie, you observe that light sensor is going to detect the light instant and it is going to adjust into theater mode where the light intensity was low, which enables us the application like automatic lighting control, occupancy detection, plant monitoring. These all are called the outcomes of this particular light sensor. Whenever we measure the light intensity, automatically we can create wonders. Automatic lighting control system, occupancy detection, plant monitoring, right? So see how many advantages are there. If you know about these light sensor, these are the outcomes which we are going to get in a fruitful way. And we'll see the next one, temperature sensor. Temperature sensor was the one which is thermistor, which is aimed, which is object. The main objective of this thermistor was to measure temperature. To measure temperature. What we are going to get if I measure temperature? With the help of this particular sensor, we are enabling multiple applications such as environmental monitoring, process control, thermal management. See how many outcomes we are going to get by using a single thermistor, which is temperature sensor, right? See the next one, voltage sensor, which is purely aimed for measuring electrical voltage, which is aimed for purely measuring electrical voltage, which is voltage sensor, where the things are going to be enabled by measuring the voltage sensor. We are designing some applications such as power monitoring, battery level detection, fault diagnostics. These are the outcomes by using this voltage sensor, right? And by integrating all these sensors with our stepper motor, which is other actuators in our Internet of Things systems, we are going to achieve a high level kind of automation system, and also we are going to control various physical environments with the help of these particular sensors. And now we will enter into the main topic, which is unipolar and bipolar stepper motor. What unipolar stepper motor and what bipolar stepper motor was. As I told you, in principles of IoT, stepper motors and various sensors are playing a vital role. Why I have used the term vital role? Because these stepper motors and these sensors are playing a major role in any kind of IoT systems. Why? Because by using this, we are achieving the correct, precise positioning and controlling the things. How these things are going to be done and how these things are going to function, we'll see in detail. Coming to stepper motor. What stepper motor was? We have seen DC motor, right? Which is going to spin continuously, where stepper motor was the one which is going to rotate in discrete steps when the electrical pulses are applied. Got it, guys? DC motors are going to DC motors are going to rotate continuously, whereas stepper motors are going to take discrete steps when electrical pulse is applied. Until that, it is not going to continuously spin. Got it, guys? That was the stepper motor. Difference between DC motor and stepper motor. See here, DC motor which is going to spin continuously. Stepper motor which is going to rotate in discrete steps when electrical pulses are applied. Got it? Right. The to make you a more precise way, step-by-step movement makes them ideal for applications which require controlling positions and common in our IoT projects. And what are the different kinds of stepper motors? As I told you, there are two kinds of stepper motors. One is unipolar, another one is bipolar stepper motor. Coming to the first topic, which is unipolar stepper motor. The unipolar stepper motor, here we are having a similar designs, which is going to be designed by taking few kind of wires, typically 4, which requires a small simple driver circuit, and also where we offer less torque compared to the bipolar. Why? Because we are only using half winding and the current flows only in one direction through the coil from the movement. This is how unipolar stepper motor will function. Coming to bipolar stepper motor, it is quite opposite. There I am using more complex designs with more wires, like 4 to 8. When I compared with unipolar, I have used only 4 wires, whereas here I am using 8 wires. Got it, guys? And the next thing was, we require a more complex driver circuit in bipolar, whereas in unipolar I am using only a less design. And also here, by using full wire binding, I am getting high torque power when compared to unipolar, whereas there only I am using half winding, so I am getting less torque power. Here I am using full winding, so I am getting full power. Right? Got it, guys? And here the current was also be reversed in coils, where I am achieving the rotation in both directions, where in unipolar I am going through only a single direction. If you observe in bipolar, I am going in both directions. To achieve the rotation, I am performing like this. This was the best differences between unipolar and bipolar stepper motors. Right. What we need to know about the stepper motor? Sir, you have narrated what stepper motor was. You guys are also have seen in the previous slide. And after that, I have started discussing about types of stepper motors. 2 types, unipolar, bipolar. And now you guys need to know how we are going to control these stepper motors in IoT, in Internet of Things exactly. Here in stepper motors, the things are going to be controlled by microcontrollers, which is going to send some signals to the stepper motor driver circuit. With those signals, it is going to specify how many number of steps and in which direction, either it is clockwise or anti-clockwise, and what the speed of rotation was. These all are the things which has to be taken care whenever you are going to control that particular stepper motor. And coming to the thing, in stepper motor, the circuit is going to translate the control signal into appropriate sequence by taking the electrical pulses for specific motor type, either in unipolar or in bipolar. And what are the different kinds of sensors which are presented in stepper motor control? Have a look, guys. Sensors, I already told you, which are going to be used in conjunction with stepper motors to enhance the control and to enhance the functionality in IoT applications. We are using these sensors in stepper motor control. I will let you know with some examples. Limit switches. Limit switch was the best example where I am using sensors in stepper motor control. Limit switches, basically I can call these switches as mechanical switches. You guys also can call it as mechanical switches, which are going to be placed at the end of a traveling range to detect when the motor has reached the maximum position for preventing over rotation and damage. For preventing damage and for preventing over rotation, we are placing sensor to know whether the motor has reached the maximum position. Right? In unipolar, as I told you, there was a winding up to here. If I place a sensor here, automatically it will update you. So it reaches the end. You can prevent damage. You can stop. Why? Because it will travel in only in one direction. Whereas the other one is going to travel in bipolar in both directions. Either it can be travel like this, either it can be go like this. So in unipolar only one direction. In bipolar, two directions. Got it? Only one way. It can here both ways. It can travel. That is why sensors has to be placed in stepper motor. And coming to the next one, rotatory encoders. In rotatory encoders also we will use these sensors for providing feedback on the motor shaft rotation. There was a motor shaft in this particular rotatory encoders. For that purpose, I am placing that shaft rotation. With this, the microcontroller can use the information for precising the position and also control the loop very easily and ensures the motor reaches the desired position accurately. For that purpose only, I am placing the sensors in rotatory encoders. And also, we need to know about different kinds of applications in stepper motors. What are the different kinds of applications which are going to be there in this stepper motor? Have a look. The first application was 3D printer. 3D printer is the best example for stepper motors. Why? Because in 3D printers we will use stepper motors for precisely taking control the movement of the extruder head. This was the head which is going to print the 3D image by laying down the filament in the controlled pattern to create a 3D image in a good way. For that purpose, our stepper motors can be utilized. Coming to the next factor, next application, which is CNC machines. In these CNC machines, we are using stepper motors to provide the cutting tools and also to work in a such place where precise parts for controlled machine. That is what CNC machine was. And coming to the third factor, third application, which is camera control system. In camera control system, generally we guys are having an experience by using the camera. With the help of these stepper motors, it is going to take the positions. We can control automatically. No need of manual zooming. No need of adjusting the cameras or focusing on some particular area by adjusting the focus of lens. This can be done with the help of the stepper motor. By sitting in front of the system, you are able to zoom. You are able to watch. You are able to find the security cameras. That's what the beauty of IoT automation with the help of these stepper motors. Either you can use unipolar or you can use bipolar. That doesn't matter. The stepper motors was an application was these camera control systems. And the next one is pick and place machines. In the automation assembly lines, these stepper motors are going to be precisely control robotic arms for picking and placing components. And generally, this can be done in industries for carrying goods. Why? Because if I use physically manpower, they are going to be tied after a hour or 2 hours for the continuous loading and unloading package. Whereas if I use robots only for picking and placing machines, in that particular scenario, I am going to place the stepper motors precisely, which is going to control the robotic arm for picking up and placing the components in the desired location as per the design. And how to choose the best stepper motor? Here, the choice is going to be depends on the person who is designing that project. Either you can go with unipolar or you can go with bipolar. Depends on your project requirement. And coming to unipolar motors, these are very simpler to control but offer less torque compared to bipolar. Whereas in bipolar, we are going to get high torque where we are precising the control but requires a more complex. Where the other thing, considering factors like motor size, torque requirements, desired step resolution, and project complexity, which is going to help you a lot. And coming to the next one, learning resources. Why I am providing learning resources to you for this particular thing was you need to search online about these particular controlling stepper motors with Arduino and unipolar and bipolar differences. There are a number of tutorials which increase your capability for doing a project. There are wide diagrams with code examples, lot of things are there. And also starter kits with microcontrollers, sometimes which include the stepper motors in driver circuits, will allow us to perform the experiment with better way by taking these stepper motor controls in practical settings. Finally, I'll conclude this particular concept called unipolar and bipolar stepper motors. If you understand this well and how the sensors which are placed in stepper motors are going to function, is going to enhance your ability. You can create IoT projects with a precise positioning and controlling capabilities, and for opening doors in a new application and innovative designs can be done with the help of this unipolar and bipolar stepper motors with sensors. That's it about this particular topic. Now we'll move into the next topic called light sensor. And what light sensors are? Light sensors are the fundamental components in many IoT applications, which is going to allow us, which is going to take our device to react and adopt the changes in ambient light, and how these are going to function and how the project is going to be integrated. However, we are integrating the light sensors in our IoT project. We will see what are the different kinds of types of light sensors. First one is LDR, which stands for light dependent resistor, which is a simple and common type. LDR is a simple and common type. Its resistance decreases, the light intensity increases. These are inexpensive but may not offer any kind of linear response across the entire light spectrum. And coming to the next one, photodiodes, and the next one, phototransistors. Coming to photodiodes, these are going to convert the light energy into electrical current. Photodiodes are the one which are going to convert the light energy to electrical current, which offers a fast response time for better linearity compared to LDRs, which is light dependent resistors, which are generally more expensive. And coming to phototransistors, these are a little bit similar to photodiodes. As I told you, photodiodes are the one which are going to convert the light energy to electrical energy. And the phototransistors, these are very light sensitive semiconductors that conduct current based on light intensity. These can be used as switches for analog light level management: low, high, medium, low, medium, high. Automatically the light brightness is going to be increased as per the level. That is what the usage of these particular light sensors, LED or photodiodes and phototransistors. And along with that, we are having ALS, which stands for ambient light sensors, which are going to be used in integrated circuits, which are going to combine light sensors with signal processing circuitry, where we are offering a digital output proportional to the light level, where simplifying integration at control microcontroller. And how we need to use these light sensors, sir? We have seen different kinds of types of light sensors such as LAS and photoresistors, photodiodes, as seen in LDRs. These are the 4 different types of light sensors, and how these 4 different types of light sensors are going to be used, we need to know. First, automatic light control. This was the first thing, how to use light sensors in our IoT. Automatic light controlling. We are using these light sensors which can be used for turning on lights or turning on dim or turning them off. These are the 3 options which are going to be utilized. These can also be used to dim lights automatically based on the ambient light levels. And coming to the next one, smart agriculture. Whenever we use these light sensors and monitor the light in greenhouse, automatically there will be a good growth in chambers, which helps the optimization of the plant growth conditions. In such a way also light sensors are going to be used. And coming to the next factor, which is security systems. By using these light sensors, we are going to detect the movement, or is there any detect in intrusion, by identifying the changes in light pattern. And also display brightness control. Smartphones and other devices can adjust the screen brightness based on the ambient light for improving readability and battery efficiency. These are the real-time examples which we are seeing in our day-to-day life. Display brightness control, which is done by most of you in your smart gadgets. Security systems, which is you guys have seen in your respective apartments or else in your organizations. And coming to smart agriculture, who know about greenhouse, they know about this perfectly. And also automatic lighting system. Nowadays people are advanced and home automations has done a good way. And in organizations also people are placing these lights. If there is a motion detection, automatically the lights are going to switch on slowly. If there is no motion, automatically it is going to be dim and it is going to be shut down. Like these, the sensors are going to be used in IoT systems. And how to connect these light sensors to microcontroller. The connection method depends on a specific sensor type. Why? Because I may use any kind of light sensor, LDRs, photodiodes, phototransistors, and ALRs. LDRs are the typically voltage divider circuits. With this particular thing, I am able to control the microcontroller ADCs. Coming to photodiodes and phototransistors, which may require additional circuitry, depends on the application, such as the example was current amplifiers. And coming to the ALS, often which have a simple connection, which require only power and ground connection, only power connection plus and minus, which is power and ground connections. Sometimes I2C and SPI communication protocol will plays a major role for that the time of data transfer in this particular thing. And how the programming this particular light sensor data is going to be done. The microcontroller code is going to read the sensor data from the sensors, and by based on that, predefined thresholds or predefined algorithms are going to take a decision on the control of actuators lights, where we are sending the data for future processing and future visualization. What are the different kinds of learning resources which improve your knowledge, such as you guys can search light sensors with Arduino or types of sensors for IoT. These things will help you to know about more tutorials regarding these light sensors, which helps you to build your projects. And also there are some starter kits with microcontrollers which is providing us to perform some experiments on this particular light sensor, and with that you are going to know about how to implement in IoT projects. And finally, I'll conclude this particular light sensor concept by adding a small info, which is you can add a layer of environmental awareness to your IoT projects by enabling them to interact with and adapt with the surroundings based on the light conditions. This is what I can say for these light sensors. Now I'll move to the next topic. As I told you, we're having another topic which is going to be discussed today, which is temperature sensor, which is thermistor. Temperature sensor with thermistor. How the things are going to be. In principles of IoT, temperature sensors are essential for monitoring and for reacting the changes in environmental temperature. These are the thermistors, which are common type of sensors and common type of temperatures in various IoT applications, where you people are going to integrate these in your projects. Now, first, what thermistors are? As I told you, thermistors are temperature sensitive resistors. What thermistors are? Temperature sensitive resistors. Here, with this resistor, the resistance value is going to change significantly when the temperature variations. Morning at 9 o'clock, the temperature is 25 degrees Celsius. 10 o'clock the temperature is 30 degrees. 10:30 it will increase. 11 it will increase. 12 it will be high. 1 o'clock it will be a little bit low. 2 o'clock a little bit low. Gradually it will be normalized by evening. Like this, temperature variations will be there. Even in night also some kind of temperature will be there. All these things can be identified with the help of these transistors only. Right? Temperature sensitive resistors these are. With this, there are different kinds of types and different kinds of packages. As I told you, bed, disk, probe, which are suitable for various applications. And these thermistors are having NTCs. NTCs means negative temperature coefficient, where we are having the meaning of resistance which decreases the temperature. When the temperature is increases, automatically it is going to switch on the fan, it is going to switch on the air conditioning system which is presented in your concerned room. How to use these thermistors in IoT? Thermistors are used in various IoT projects to monitor the temperature in, and also environmental monitoring systems which are used in homes, greenhouses, or industrial settings. These are the things where we can use these thermistors. Wearable devices like smartwatches to track our body temperature, smart applications like refrigerators, ovens to know about the temperature controller, 3D printers to monitor the extruder on the bed temperature for optimized painting, and also how to connect these thermistors to microcontroller. Thermistors, as I told you, which is a temperature control resistor, where these thermistors by themselves do not provide any direct temperature reading. Why? Because they require a circuit to convert the resistance change into voltage level, which is readable by the microcontroller. Normally we are not able to read it. Only microcontroller was the one which is able to read the voltage level, right? And there was a common method which is voltage divider circuit, which includes thermistor and a fixed resistor. And this thermistor is going to identify the changes in temperature and also the voltage across when it is going to be changed. And how microcontroller code for thermistor was: microcontroller which is going to read the voltage from voltage divider circuit by using analog to digital converter, which is ADC. Based on the thermistor data and conversion equations, the code is going to calculate the actual temperature from voltage readings. And also the temperature data can be used in various purposes, such as displaying temperature on LCDs, and also send it to cloud from remote monitoring, and also controlling various kinds of devices which are temperature thresholds. Example, turning on a fan when the temperature goes high, turning on automatically air conditioning system when the temperatures must get too high. These are the things which we need to know. How we need to calibrate this particular thermistor. As I told you, this thermistor behavior can vary slightly between two different components. When you are having high precision and low precision application. When there is high precision application, consider calibrating the thermistor using reference temperature source. And with the help of multimeter only, we are able to ensure the temperature readings in your code. What are the different kinds of learning resources which might be helpful to you for knowing about this thermistor? Knowing about the temperature sensor with the help of the thermistors, right? Search in YouTube thermistor with Arduino, or else temperature sensor circuit for IoT. You are going to get a number of tutorials which increase your capability of knowing this temperature sensors in more advanced, and which might be helpful for using the temperature sensors with thermistors in your IoT projects. And there are a number of starter kits with microcontrollers are oftenly used, which includes thermistors and resistors, which allows you to perform various kinds of experiments to measure on temperature. And also you will have a good control on IoT projects. I will conclude this particular concept by stating a word: temperature sensor with thermistor. But their integration dually with microcontrollers can equip you a lot whenever you are doing your IoT projects to sense and to react the temperature changes, right? Opening doors multiply when you are expanding your applications in various fields. That I can see. With the help of these three things, unipolar and bipolar stepper motors using sensors and light sensor and temperature sensors with thermistors. These three concepts, by you implementing these three concepts, you guys can create wonders. You guys can make automation possible in IoT systems and create n number of applications with the help of these sensors and create good projects in future. I hope. That's it, guys. That's it for today's class. We'll meet in the next class with the next three concepts. As I promised you, we'll meet in the next class. That's it. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.